LM Studio hit 108.5 tokens per second on a 7B model with an RTX 4090, and Ollama can run multiple models in parallel at the same time. Two totally different strengths. One very real choice you have to make. Pick the wrong one, and you're either stuck in a terminal you hate or locked out of the multi-model workflows you need. Local AI tools are moving fast right now, and which one you pick shapes your entire workflow. So I went through 7 verified sources, 24 data points, and 5 head-to-head comparisons between LM Studio and Ollama. Every claim traced back to a specific source, no cherry picking. The final verdict comes down to one thing that has nothing to do with speed or tokens, and that's how comfortable you are with a terminal. Get that wrong and you'll spend more time fighting your tool than actually running models, which is exactly why I built the conditional verdict at the end. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. I've run both LM Studio and Ollama across real workflows, and what I found surprised me in a couple of spots. So let's get straight into the tests and see what actually holds up. You've probably heard both tools are great for running local models, and yeah, they both do the job. But if you're loading a 7B model for daily use or spinning up multiple models for an automation pipeline, the tool you pick changes how fast you can actually move. And we're talking the difference between a 5-minute setup and a 45-minute Docker rabbit hole. Test 1 is model loading and inference speed. The number I kept seeing was 108.5 tokens per second for LM Studio on a 7B model with an RTX 4090. And that's the kind of stat that makes you think one tool just wins this outright. Spoiler, it's more complicated than that. So LM Studio hits 108.5 TOKS on a 7B model with an RTX 4090, which is genuinely fast for local inference. Ollama, on the other hand, scaled up to a 70B model on dual RTX 5090s and pulled 26.85 TOKS. The problem is there's no published test with the same model on the same hardware for both tools, so I can't give you a clean head-to-head number here. The data just doesn't let us call this one. Different models, different hardware, genuinely incomparable. Test 1 is a tie. Scoreboard stays at 0-0, and we move on to where the gap gets a lot more obvious. Test 2 is the user interface and setup. The day you sit down to run your first local model and you're staring at a blank terminal with no idea what to type, you lose maybe an hour just getting the thing installed. That's a real cost, so I looked at first run experience, GUI availability, and how much friction each tool puts between you and actually chatting with a model. Okay, so LM Studio is a download, install, open, browse models, click download, and chat kind of experience. No terminal needed at all. Ollama is CLI first, and if you want a GUI, you're setting up OpenWebUI through Docker, which is genuinely extra steps. LM Studio's CLI exists, but it's clearly secondary, and Ollama's CLI is faster for scripting once you know it. LM Studio takes test 2, and it's not close. The GUI is the best local AI chat experience for non-technical users I've seen. One-click model downloads, a built-in GPU wizard, 0 Docker setup. That puts LM Studio up 1-0, and the margin here was bigger than I expected going in. Test 3 is multi-model management and switching. A solo dev running a coding model and a summarization model at the same time needs to know, can your tool actually keep both loaded without killing context every time you switch? Because if it can't, you're reloading and waiting every single time, and that adds up fast. Ollama has native multi-model parallel execution. You set Ollama max loaded models and Ollama num parallel, and multiple models stay resident with a configurable keep alive default 5 minutes. LM Studio loads one model at a time, and switching via the sidebar resets context every time. LM Studio's sidebar is easier to use visually, I'll give it that, but Ollama's power user control is in a different league. Ollama takes test 3. LM Studio's visual model switcher looks good, but running multiple models simultaneously with configurable keep alive is a genuine capability gap. LM Studio just doesn't have right now. Scoreboard is tied at 1-1, and the next 2 tests are going to decide this thing. Alright, so it's tied at 1-1, and there are 2 tests left: API integrations and memory efficiency. The API test is where I found something about LM Studio I genuinely didn't expect, and the memory test is the one that matters most if you're running bigger models on limited GPU, so stay with me. Test 4 is API compatibility and integrations. Both tools expose an OpenAI compatible endpoint, so you might think they're basically the same here. The real question is what happens when you try to wire one of these into a custom app with a TypeScript or Python SDK, and that's where the gap shows up. Both tools give you an OpenAI-compatible REST API, which means most tools work with either one. But LM Studio also ships official TypeScript and Python SDKs, and it supports an Anthropic-compatible endpoint on top of OpenAI. Ollama doesn't have official SDKs and is OpenAI compatible only, though it does have a bigger third-party client ecosystem with 126K plus GitHub stars and clients like OpenWebUI and John. LM Studio takes test 4. Ollama's massive ecosystem is impressive, but official SDKs plus Anthropic endpoint support is a real developer advantage that community clients can't fully replace. That puts LM Studio ahead 2-1, and now it all comes down to memory efficiency. Test 5 is memory efficiency and resource consumption. You've probably had the moment where you try to load a 13B model and your GPU just runs out of VRAM, and the whole thing crashes. That's the failure mode here, and which tool handles it more gracefully could save you a lot of frustration if you're working with limited GPU memory. Both tools run on llama.cpp under the hood, and both support 4-bit quantization, so the baseline is identical. Ollama can spill to system RAM when VRAM runs out, which is a practical safety net. LM Studio has CUDA 12.8 optimizations that could give it an edge on newer RTX GPUs, but I couldn't find documented VRAM spill behavior for LM Studio, so that's a real gap in the data. Now, the gap here is smaller than it looks. Both tools use the same runtime and the same quantization formats, so if you're on a well-spec'd GPU, you probably won't feel a difference day to day. The VRAM spill advantage for Ollama really only matters if you're right at the edge of your GPU's memory, say, trying to run a 32B model on a card with 24GB. These two are too close to call on memory management. Same runtime, same quantization, and the VRAM spill over CUDA 12.8 trade-off depends entirely on your hardware. Test 5 is a tie. Final scoreboard, LM Studio 2, Ollama 1, 2 tied. LM Studio wins on user experience, full stop. It's the only local AI tool with a polished desktop GUI you can use in minutes, one-click model downloads, a built-in GPU wizard, zero Docker setup. It also ships official TypeScript and Python SDKs, and it's the only one here with an Anthropic-compatible endpoint alongside OpenAI. CUDA 12.8 support is a bonus on newer RTX cards. Ollama wins on power and flexibility. Native multi-model parallel execution is a real feature LM Studio doesn't have. You can run multiple models simultaneously with configurable keep alive. It's fully open source under MIT, so there's no lock-in. The third-party ecosystem is massive at 126K plus GitHub stars. And VRAM spill to system RAM is a genuine safety net for big models. So here's the decision rule. I went in thinking speed would separate these two. That 108.5 tokens per second number looked like a knockout punch, but the real differentiator turned out to be the terminal. If you want to chat with models today with zero friction, go LM Studio. If you need parallel models, scripting, or open source control, Ollama. Pick the tool that fits how you actually work. If you want to go deeper on the CLI side, I ran Ollama against John AI next, and the multi-model story gets a lot more interesting. When you add a proper front end, the gap between them is way smaller than you'd expect, and that video is already on the channel.